All right, chapter 4, the video problem for this week is that based on the reactions we have studied, design a synthetic route to making 0.750 grams of barium sulfate. We have to give the balanced reaction and the appropriate concentrations and volumes of the reactants. Okay, so in order to do this, first thing we have here is we have the barium sulfate. So that's what we have to get. So if we write our equation, we know that barium sulfate is going to be our product. Now, the things that go into barium sulfate, one is going to be barium. So we put barium over here and we put sulfate. So we're adding barium and something, barium and X, plus Y or something else and sulfate. And that's going to give us barium sulfate plus some other thing. And so the ones that I chose to use are NO3 and calcium, and it's going to give us calcium nitrate. And so we just do this. Barium's a +2 charge, so the nitrate, that's going to be a 1- charge. It's got to be 2 of them, so 2 nitrates for every barium. Calcium is a +1 or +2 charge, and so calcium sulfate, that's going to give us CaSO4, 2- charge plus a 2+ charge. And then that's going to give us over here calcium nitrate. Now, calcium is a +2 charge, nitrate is a -1 charge, so we have to have 2 of the nitrates. Now, this is all balanced. We have 2 NO3s over here. We have 2 NO3s over here. 1 SO4, 1 SO4, 1 calcium, 1 calcium, 1 barium, 1 barium. So this is our balanced equation, is all of this right there. Okay, so now we have our balanced equation. Now we're given that there's 0.750 grams of barium sulfate. And we need to find the concentrations and volumes of these two products, or these two reactants, sorry. So how we do it is we take 0.750 grams of barium sulfate. We know that for every 1 mole of barium sulfate, there's 233.3906 grams of barium sulfate. We find that by taking the molecular weight of barium and the molecular weight of sulfate. We add those together, that gives us 233. And then we just divide 0.75 by the atomic weight of barium sulfate. That gives us the moles, which is 0.0032 moles of barium sulfate, and that's for every 0.75 grams. Now, we see here that our ratio of barium sulfate to barium nitrate is for every 1 mole of barium nitrate, we have 1 mole of barium sulfate. Same thing with calcium sulfate. We have 1 mole of calcium sulfate for every 1 mole of barium sulfate. So our ratio is 1 to 1. And so we take the moles of barium sulfate, divided by the moles of barium sulfate. For every 1 mole of barium nitrate, we get the same, 0.0032 moles of barium nitrate. Do the same thing for calcium sulfate, boom, and we get 0.0032 moles of calcium sulfate. So then this comes to our answer. So the concentration is going to be our molarity, and that's going to be moles per liter. So we get to choose kind of what our concentration or what our volume is. So if we choose 1 liter, then that means for every 1 liter of barium nitrate, we have the right amount of moles, 0.0032. And so 0.0032 moles per liter is our concentration, and we just say that we have 1 liter. So if we add 1 liter of barium nitrate and 1 liter of calcium sulfate, we're gonna have what's going to give us our 0.075 grams of barium sulfate. And so that's it. Now we're given 0.0750, so we have 3 sig figs there. We got to go to 3 sig figs here. So we have 0.003 molarity, moles per liter, barium nitrate for every 1 liter, and that'll give us our answer of 0.750 grams. And that's how you go about solving that question.